Now the distance between two parallel lines is given by the formula mod of C1 minus C2 upon square root of A square plus B square. Okay. So we are given two straight lines, equations for the straight lines we are given, and I have just drawn a figure that is in front of you. Two parallel lines with the given equations. Now let the two straight lines be ax plus by plus c1 is equal to 0, equation 1, and ax plus by plus c2 is equal to 0, equation 2. Now why we have not changed first two terms? Because if you remember, when we have reduced a normal equation to a general form, and general equation, I just have gone through a formula that when the equations are parallel, then this is the condition. When the equation are perpendicular, then equation for the second line, parallel line or perpendicular line, what it will be. Okay. So now, by definition of parallel lines, distance between the parallel lines, this for parallel lines, is same throughout. Same throughout. Now, according to the figure, line, now I have written here ax plus by plus c2 is equal to 0, that is line 2. Line 2 meets x-axis such that y is equal to 0. Okay. Now, putting y is equal to 0 in equation 2, we get x is equal to negative of c2 upon a, negative of c2 upon small a. Okay. Therefore, coordinates of a, now therefore coordinate of point a will be negative of c2 upon a comma 0. So this point a, it is negative of c2 upon a comma 0. Okay. Now let distance D is equal to AB. I have mentioned one point A and this is the B and it is a perpendicular. Okay. Now D is equal to distance from point A on equation 1. Point A on equation 1, that is AB. Okay. So D is equal to, now we are having first equation AX plus BY plus C1 upon under the root A square plus B square. Now D is equal to A times negative of C2 upon A, putting substituting values of x, plus b with 0 plus c1 upon square root of a square plus b square, and this is equal to c1 minus c2 upon square root of a square plus b square.